Hello, I am Erim. Welcome to aliceinphysics.com. With this video, I am starting to explain the subjects of the Alice Law book. I will explain the subjects one by one in various videos. This is the first video in the series. Let's see it all together. Now, firstly, what is Alice Law? What is Alice Mathematics? Of course, I need to give information on this subject. Alice Law is in essence the electromagnetic theory. It is nothing but the electromagnetic theory. It is not another theory. Alice Law is exactly the electromagnetic theory. There is a difference, like this, electromagnetic theory cannot express the electromagnetic interaction between reference systems moving relative to each other due to a deficiency from the past. So, there is a deficiency in theory. Alice Law makes up for this deficiency of the electromagnetic theory. It defines the rule of electromagnetic interaction between reference systems that move relative to each other, defines the mathematics, and examines and explains the possible consequences. This is Alice Law. Now, in the narration of the book, I had used the word signal instead of electromagnetic wave in the past, because this makes it possible to explain the subject more fluently. Here I want to continue the same method. First of all, let's enter to the subject by categorizing a signal and categorizing it according to reference systems. Now, we see a plane here. We also have a station here. Plane is sending a signal. Now, according to this reference system that receives this signal, this signal comes to itself, so the incoming signal is in the state of an incoming signal for itself. It is the reference system that sends the signal. Since it sends the signal itself, this signal is in the position of an outgoing signal for itself. There are also traveling signals. That's it. Now, it neither sent the signal, nor did it come to it. It goes from one object to another. For this reference system, this signal falls under the traveling signal category. Each category has its own characteristics. Let's develop this a little more. The things that are important for electromagnetic theory are definitions of incoming and outgoing signals. These are the main things. These are the definitions that build the Alice Law. Incoming signal definitions and outgoing signal definitions. Let me step aside. Maybe you want to stop the video and read. Now, what is incoming signal? We call incoming signal is a signal coming to an object itself. Alice Law accepts that the speed of the incoming signal to itself is always c. It accepts as a prediction. In other words, it takes in the knowledge coming from the past into itself. Nothing new here. Therefore, this definition is also valid for electromagnetic theory. The problematic part is outgoing signals topic. Alice Law approaches the issue of outgoing signals as follows. Now I'm sending a signal to an object. In order for the speed of this signal to be c, the object must be motionless relative to me. If the object is in motion, the speed of the signal I send cannot be c relative to my reference system. Alice's law says that. What happens? If the speed of the two reference systems relative to each other is v, accordingly, the signal speed is c plus v if the reference systems are moving away from each other, and c minus v if they are approaching. Alice's law says this in summary. Now, actually the electromagnetic theory could have defined of incoming and outgoing signals 130 years ago. I mean electromagnetic theory could have done it. However, this breakthrough could not be achieved in the past. As a result, the theory of relativity was brought to the agenda first. And then Alice's law came to the fore as a corrective theory. Now, incoming and outgoing signal definitions paved the way for a mathematics that I call C plus V, C minus V mathematics. This math is the one that electromagnetic theory should have. In other words, electromagnetic theory will use this mathematics in the future, and thus it will have a structure that can express the electromagnetic interaction between moving objects. C plus V, C minus V mathematics is consequently a mathematics that describes the signal speed according to reference systems. Now, we will see the setup, how this is set up. This is our topic page. We will see everything on this page. Now, the subject is as follows. We have a plane here. Plane is moving from point B to point C, like this. We also have a station here. Now, when the plane is at point B, it starts sending a signal, like this, it's sending a signal. As soon as the front side of the signal reaches point A, the plane is at point C. Now we connect points A and C with a straight line, so we got a triangle. This triangle is called the Doppler triangle. I gave this name. This is a Doppler triangle. The characteristic of the Doppler triangle is that the triangle is a triangle whose side lengths are determined by the time of arrival of the signal. Let's find the side lengths of this triangle. Now, this is an incoming signal relative to the station, isn't it? What was the incoming signal definition? A signal coming to an object according to itself. How fast is this? Always c. So what would the distance d1 be? Distance d1 becomes d1 equals ct0. The arrival time of the signal times the speed of light gives the distance d1. What is the distance d3 here? Distance d3. If I call the speed of the plane u, this triangle is determined by the arrival time of the plane, therefore u multiplied by t0, so the plane will move during t0. U times t0 gives the distance d3, d3 equals ut0. So the BC edge is okay. So what is the AC edge? Let's find it too. We follow a route to find this out. I draw an arc with center point A and radius equal to the line AB. Like this. I mark the place where it intersects with the AC line as point O. Now AO and AB are equal. So what is OC? OC is a measure of how far the two reference systems, the plane and this station, have moved from each other during the time t0.
Uzaklaştığını t0 süresi boyunca birbirinden ne kadar uzaklaştığını gösteren bir ölçü.
If I describe the speed of moving away as v, then it will be x equals vt0. This is how I can define distance x. So what is d2 distance? I mean AC distance. It would be AB plus OC. So this happens. Thus, we calculated the side lengths of our triangle. As you can see, the arrival time of the signal is on all three sides. Now, look here, we see a C plus V. If I prove that, relative to the plane's reference system, the C plus V is the speed of the signal which is sent by itself, I will have set up Alice's law, right? Let's do this. We are doing this like that. Now, our plane. Now, I draw a line that is connected to the plane at one end, equal to AC distance and parallel to it. Like this. This line is connected to the plane at one end, moving with the plane, equal to AC distance and parallel to it. Now, the signal is sent from point B. Look, the signal is sent from point B according to the reference system of the plane. The front side of the signal follows this blue line and reaches point A. Isn't it? Let's see more clearly. The signal departed from point B, the front end of the signal. Look, it reaches point A by following this line according to the reference system of the plane. So how long does it arrive? Of course it arrives in t0 time. So d2 divided by t0 here, according to the reference system of the plane, is the speed of the signal it sends. Thus, I have shown that C plus V is the signal speed, it is the outgoing signal speed. We've always talked about C plus V, let's also see C minus V. How does C minus V work? Look, here the plane was moving away. Like this. Well, let the plane approach, come to this way. Let it move in the direction of approach, like this. Then what do? We subtract OC distance from AO distance. What happens here? It becomes D2 equals C minus V times T0. What is the outgoing signal speed? C minus V equal D2 divided by T0. Thus, we set up Alice's law. Incoming signals and outgoing signals. We also saw what C plus V C minus V mathematics is. We have seen where the electromagnetic theory went wrong and where it was missing. Therefore, actually, if the electromagnetic theory had made such a measurement today, so if it measured the interaction between moving reference systems, the velocity of a signal, which didn't do that. It could not find C plus VC minus V mathematics because it did not do this, it couldn't reach this mathematics. What it has to do is measure the speed of an outgoing signal between moving reference systems and has to do this. I will discuss how we can do this measurement in my next video. Now, here, until now we have set up Alice's law. We saw C plus VC minus V mathematics. We saw where electromagnetic theory was wrong. We briefly touched on how the electromagnetic theory should make a measurement. We will continue where we left off in the next video. I say goodbye for now.